I would like to now introduce the sum and difference formulas for the trig functions. There's actually 6 of these, and we do them in pairs. There's a pair for cosine, a pair for sine, and a pair for tangent. There's no need to have a secant, a cosecant, or a cotangent, and I'll explain why later on. Okay, I need you to memorize all 6 of these formulas. You might want to take a moment and you might want to pause the video to write these formulas down. Now, I'd like to somewhat explain these formulas just as far as a way that will help you remember and memorize the difference between all 6 of these. First of all, on cosine, if you notice, the first two factors that are multiplied together both have to do with cosine. Okay, this particular one is a sum, and if you'll notice, the first sign in there is actually the opposite of the sum, it's subtraction. And then notice that the next two factors are both sines. Now, what I've chosen to do is I've chosen to always have my angles being consistent. In other words, in all 6 of these formulas, you see alpha first and you see beta second, and that's also the way they show up in the right-hand side of the formula. Okay, the first one, you have cosine of the sum of two angles equals cosine of alpha multiplied by cosine of beta, and then minus sine of alpha multiplied by sine of beta. Okay, the next one down, cosine, if you'll notice that this is the difference of angles. Okay, first of all, you see that cosines come first. You have an opposite sign than what you have in parentheses at the very beginning of the problem, and then you have your sines. Okay, coming on down to sine, you have sine of alpha plus beta. First of all, notice that you have a mixture of sines and cosines as far as a product. You have the same sign as what you originally had over here, and then you also have a mixture, but they're in reverse order for that second product. Okay, a similar thing is going to happen down below on the subtraction problem. You have sine of alpha minus beta. You have a mixture of sines and cosines here. Same thing over here, a mixture of sines and cosines, but in the reverse order, and then the opposite the same symbol in the middle. Looking at tangent, you see that tangent for either sums or differences is always equal to a quotient. On the top, the sign is consistent with whatever sign you had originally. The same thing on the subtraction, you see that's always the same. And then on the bottom, you always have 1, and then the opposite sign of whatever you have on top going on in the denominator. Okay, so these 6 formulas, we need to have them memorized. I will not give these to you on any kind of exams. Let's look at an example and see where these formulas would be used. Okay, my example here is find the sine of 15 degrees. Okay, now 15 isn't one of my special angles, like a 30-degree angle is 60 or 45, or even a quadrantal angle like 90 or 180, 360. But if I can figure out a way to rewrite 15 degrees and do it by either using a sum or a difference, then I can use one of my sum or difference formulas from above to rewrite the problem and hopefully write it in a way that has angles that I do know in it. Okay, think about 15 degrees. Rewrite 15 degrees as a sum or difference using angles that you do know something about, your special angles. One possible way to do that would be to use 45 degrees minus 30 degrees. We know something about both 45 and 30 degrees. And so we're going to take what we have originally here and we'll just rewrite it as sine of 45 degrees minus 30 degrees. Okay, now there's no one unique way, obviously, to rewrite 15. Okay, in this particular case, I chose to rewrite it using a difference. Okay, now we want to use one of the formulas that I wrote down up above. This one is obviously a difference from what I have in the middle, so I need to go up from where I have above, and I need to choose which formula I'd want to use. This would be the formula for this particular problem. Okay, I'm going to copy the problem down, or the formula down below, and then we will use it. Okay, so let me actually put here that this is going to be the formula. Okay, the formula that I will use says the sine of alpha minus beta is equal. remember that here you have a mixture of sine and cosine functions. So it's sine of alpha multiplied by cosine of beta. The actual sign that you have between the alpha and the beta originally is kept the same, so it's minus. And then you also have a mixture, but they're in the reverse order. And so you have cosine of alpha and then sine of beta. Okay, let's apply that in the problem that we have here. All right. So on here, our alpha is 45, our beta is 30 degrees. So sine of 45 minus 30 degrees is equal to sine of alpha, which is 45, times cosine of beta, which is 30 degrees, minus cosine of 45 degrees times sine of 30 degrees. Okay, so I've taken what I had originally, which was sine of 15 degrees. My very first step was to rewrite it using either a sum or a difference that I was familiar with. And then my second step is to actually plug it into the right-hand side of my appropriate formula, and then that will result in something that you'll be able to compute without a calculator. Alright, for this I'm going to need at least two different pictures. I have 45 and 30 degree angles in here, and so what I'm going to do is I'm going to come over to the side and I will draw both of these. Okay, a 45 degree angle, we see this is in quadrant 1. And I'll label the sides. I have 1 square root of 2. And then I need a 30 degree angle, so I'll come down here, draw me a 30 degree angle. I have the square root of 3, 1, and then 2 for the hypotenuse. And then from here, each piece I will rewrite with its appropriate ratio for that particular angle. In other words, sine of 45 degrees is the ratio of y over r. In the 45 degree angle, y is equal to 1, r is equal to the square root of 2. For cosine of 30 degrees, I'll look at my 30 degree reference angle down below. I'll say cosine I know is x over r, so that's the square root of 3 over 2. Bring down the negative sign. Cosine of 45 degrees, well, that's x over r, so 1 over the square root of 2. And then sine of 30 degrees. Sine is y over r for the 30 degree angle, so 1 over 2. Now from here, I need to show you how to reduce these kind of problems. First thing, multiply your fractions. In other words, these two fractions need to be multiplied, these two need to be multiplied. Okay, that would result, just multiply straight across. We'd have the square root of 3 over 2 roots of 2, and then minus 1 over 2 roots of 2. Now at this point you can see we have a common denominator, so we can actually combine these two together. So we'll have square root of 3 minus 1 over 2 roots of 2. And the last step at this point is to rationalize the denominator by multiplying by whatever's underneath that root. And so we see a square root of 2 in the denominator. We need to multiply the top and the bottom by the square root of 2. The top is 2 terms, so we need to distribute into here. The bottom is not 2 terms, we just need to multiply straight across there. In the top, if you have 2 roots, you can multiply the numbers under the roots, so the square root of 2 times the square root of 3 is the square root of 6, and then negative 1 times the square root of 2 is just negative square roots of 2. On the bottom, we have the constant 2 that we can just leave out in front, and then the square root of 2 times the square root of 2 is just 2. And then finally simplify to the square root of 6 minus the square root of 2 all over 4. This concludes my first example of using sum and difference formulas.